Welcome to Tribecast. We will be doing a webinar with David today. Is about his topic. Test flakiness is a common issue, and you aren't the only one facing it. Make sure you watch this session till the end because David is going to be sharing a lot of actionable tips and tools that can help you reduce the test flakiness in your test. Before starting, a huge shout out to Browser Stack, our exclusive sponsor for all our community events and premier sponsor for conferences. About David, he's currently working as a senior SDET at Disney Television Animation. I'll just call up David on the stage.
There we go.
Perfect. Perfect. Thank you very much for joining. David, can you give us a brief intro about yourself and then we are good to go?
Get my screen shared really quick. Hi, everybody. My name is David Ingraham. I'm a senior SDET at Disney Television Animation. You'll have to forgive me. I'll say it early. I'm actually getting over a cold, so I'll be drinking a lot of water throughout this presentation. So I'm sorry about that. But it's a huge honor and to kind of be invited and to contribute to this community. And I'm just excited to get to know everybody a little bit more. I've been writing automation tests and frameworks for about 5 years and especially focusing with Cypress for about 4 years. And let's, I guess, dive into it. So the topic we're going to be focusing on, of course, is test flake. This is something that we've all faced, right? It's incredibly frustrating. And test flake is when a test runs and passes maybe one time, but fails another time without any apparent reason. You get an inconsistent result. This is a big burden and drain on every single tester. We've all been there. So this course and kind of this topic is going to be breaking down the different types of flake, how I've categorized them at a high level, diving into some code to provide some visuals, and then some solutions on how you can help harden your tests so they are always more confident. I'm going to be using Cypress for all my examples, but I want to focus more on the concepts rather than just Cypress the tool. So in the code itself, because I know not everybody is a Cypress user, so I just hope you can still walk away with the same concepts and ask yourself the same questions, even though the tool I'm using isn't the same. I am curious to know about the community, and I am following the chat as I go. So if you do have time whenever, I would love to know what tool you use, what your guys' experiences are, just in case I can maybe address different things throughout the topic. First off, though, why do we even care about test flake at all? So fundamentally, we write automation tests, of course, to catch application bugs faster and with increased reliability. So having the confidence that your test results are accurate is, in my opinion, the single most important aspect of your test. If you can't trust when your test is going to fail, then its fundamental purpose is gone. It's test flake is it's common, right? It happens to everybody, and honestly, it's okay. It's really easy to write a test, but it's very, very hard and takes years of practice to write really resilient ones. However, being aware of when different types of flake can occur is crucial in taking your test suite to the next level. The more variables that you can control, which is what we're going to focus on talking about and account for, means increased test result confidence long term. So, what are the bad things about test flake, though? What are all of the actual impacts that it can happen, that it can bring to your test suite and your team? So, there are a lot of bad impacts of flake, right? So, these are just a small subset. I'm sure there are many more, but having test flake decreases obviously your test confidence. If you can't trust your test, then it's useless, right? It also decreases engineering trust. I think we've all been there, or at least I have, where I go to a developer or another engineer and I tell them something is broken when in fact my test was just unreliable. I was essentially the boy who cried wolf about a broken test case. So not only did I take up my time, but I took up their time, and maybe I broke a little bit of trust with my analysis when I had that kind of communication. You don't want to scream about a fake problem, right? It also decreases in productivity, of course. You don't want to be focusing on fixing and patching tests over and over again when you could be focusing on writing new tests or creating new features. It results, of course, in missed bugs. What if you actually have a test pass when it shouldn't? We always focus on tests that fail when they should, but what if it's the opposite? What if your test is actually passing and it's covering up a real issue? And then that real issue goes to your customers. So it kind of goes both ways. You have to really trust that when a test passes, it truly is passing. But when a test fails, it truly is failing. You don't want these false negatives or false positives. And of course, it increases in debugging time and engineering costs long term. It's a huge burden and something that you want to get really kind of uh, experienced in over time and learning to ask the right questions so you don't have to spend all this time banging your head rewriting the same thing over and over again. So let's talk about what happens if you leave test flake unaddressed and the impacts that it has long term. So I have a graph here to kind of represent this visual test suite. So we can pretend that we start with 10 tests and only one of them is flaky though. So it fails and whatever, it's only 10% of our test suite, right? It's really minor. So we kind of ignore it. And then we get to 50 tests. But now 10 tests are flaky. But again, it's only 10% of our test suite. And 10% is, it's still small, but 90% is working. So it's like, okay, it's fine. We ignore it. And so we write more tests and then we get to 100 and we get to 1,000 tests. And then, as you can see with that red line, the actual flake amount, even though our flake percentage is staying the same, is going to continue to increase. We're actually ignoring, and our tech debt is scaling really, really fast, almost to the point where if we ever wanted to go back and address all this tech debt, it's going to be impossible to do. Which is why it's super important to attack flake early. The best advice I can give to someone who wants to begin debugging and addressing their test flake is just to do it right away. It's just a habit thing, and you need to take time out to remediate it then and there. When you context switch, you kind of lose what's fresh on your mind, and chances are, if you had a test that was working before, whatever introduced that flake is a really recent change, right? You don't want to forget about that, revisit it a month later, and then try to remember, oh, what could have happened during that time. If you're not able to, I guess, address the flake early or investigate it, you can always quarantine your tests, which essentially means just skip them until you have the bandwidth to investigate them. Don't leave them running and creating false failures, kind of muddling up your test results in the code. Also, don't rely on test retries. I was really guilty of this early on, right? Where I had a test that would fail, even though I think it should. Then I just rerun the test and it passes. And I'm like, okay, all my tests pass. That's fine. Go ahead and ship the code. What I was doing though, is I was potentially actually covering up real problems, either in my test code, the application, my environment, and just kind of praying and hoping it would go away. It's a really bad pattern and one you shouldn't depend on if you want to have true confidence in your test suite. Finally, worst case scenario, if you can't fix a test, just try to cut your losses and fail fast. If your test isn't bringing the right value, is it actually useful at all? And do you need it? So I've organized some types of test flake that I've seen throughout my career into these kind of 4 different categories. And I'm sure I've missed some, but I've tried to include as many as I can. The 4 categories that I'm going to be talking about are tool understanding, test independence, local versus pipeline, and then good flake, which what could that even mean? Why would flake be good? So we're going to take a look at some code now, and all of this is going to be in Cypress. And just kind of remember the focus will be on the questions to ask yourself and the concepts instead of the actual code if you're not a Cypress user. So let's dive into it. Hello, everybody in the chat. I also am looking at your messages as well. I am curious if anybody is a Cypress user or if you are Playwright, Selenium. I guess feel free to let me know, and excited to meet you all. So let's take a look at some code. So the first type of test flake, and a very basic one that I think a lot of people overlook, is just understanding the tool you're using. Do you actually truly know and comprehend the commands you're using in your tool, the tool itself? How does it work? For me, this is the fundamental thing, and I think a lot of people overlook it. They skip the documentation, they skip the tutorials, they kind of just dive into it. And yeah, you could probably get it to work, but do you know the best way to do it? could you accidentally misuse the tool ever so slightly? For me, I always think of it like woodworking or like house tools. I'm really bad at this, by the way. That's why I'm a software engineer. But if I were to have to like hang something on my wall, I get a drill, and do I even know what the right tip to the size of the hole to drill? Do I know how to see, like, I don't even know the right terms because I'm really bad at it. So that's why I have to use documentation to make sure I'm using the drill correctly, so I know that I'm not going to have to redo that hole and I drill 5 holes into my wall. I think that's the same thing when it comes to test automation. You have to understand the tool you're using, or you're going to redo something 5 times until you get it right. So it's crucial to read up on the documentation, watch tutorials first. A couple examples with Cypress are, and I'm going to dive into a couple commands about how you can potentially misuse them, or how there can be some flake using them. So I have a very, very simple application here. It's literally a HTML document. So it's not a real application, right? I'm not really actually doing anything behind the scenes, but it's just going to prove as an example for this presentation. And what I'm doing is I'm visiting that HTML, and I want to validate that a specific header is visible. And let me pull up really quick. I think, here we go. This is it. See, again, it's not a very pretty website, but all I'm doing is validating that this header right here is visible. So if I want to select this header, the most common way to do that with Cypress is cy.get. But as you can see, I have a ton of different ways to actually get this element. I can get it using the HTML tag. I can do it the class, the ID, an attribute, a custom attribute like a data-test ID. I can use it. I can get this element using other elements. So I can get a different element and find the element within that element. I can get all elements, take the first one, and then also validate it that way. I can even use cy.contains and get it by text. I can get it by element in text. I could use other elements to get it by text. You could see there are 100 different ways, maybe not 100, but a ton of different ways to get one single element just to validate it's visible. So how do you know, diving into it, which is the best way to do it and which is going to be the most resilient? Now, there are a lot of different opinions on selectors. I'm not going to get into all of them, but what you can see, though, is that some of these might have some issues over time versus maybe some other ones. For instance, if I run my test, let me actually pull it up really quick. If I can find out which screen it appeared on, just so I can show you that it is going to run. So again, see, it's a very fast test. I'm just validating some text, right? What happens if my text ever changes? So I just add like an X in here, and I save this, and I rerun the test. What we'll notice is that my get commands are going to succeed, but all of those contain commands, right, that were dependent on that specific text is now going to fail. So half of my commands would have succeeded if I got the elements this way, but these commands would fail. So these are dependent on specific text. Is that okay, though? How often is this text going to change? So these are the kind of questions you have to ask yourself. What about cy.get? Did you know that cy.get always returns all matching elements? This doesn't mean I'm only going to get one element. So what if I accidentally added a second header class and I validated that they were visible? Or what if I wanted to actually go in here and validate some text, and I wanted to say that I want my header and I want to validate that it contains test projects? Now, if I have two headers, what cy.get's going to do is it's going to get all elements, and it's just going to look for any one of those elements that contains my text. Is that good or bad? What if the actual element that contains this text is the wrong one? So this test would still pass, even though maybe the text is in the wrong part of the page. So do I fully have confidence in this? I'm not really sure. It could give me a false positive, even though it should have maybe failed because I wasn't getting the specific element on the page. There are a ton of different things about selectors. I could spend probably an hour on these. I'm going to move on. Just to say, I personally prefer data-test ID attributes. I think they're the most solid. They're the least likely to change in your application, but I know a lot of people have different opinions on this. Okay, so another thing that another command is cy.intercept. So for those that don't know, cy.intercept essentially allows you to stub or listen into a request in your application. what I've done here is I'm just listening in on that Flickr request, which is supplying all the images, and I'm just returning a status code of 200. So in my test, what I want to do is I want to wait for my API call to finish, and then I want to validate something is visible on my page. So if we run this test, let me go ahead and save that and then switch back to my test. We can see that it passes, right? But that's because I'm loading an HTML page. If this had any sort of like any minor amount of weight booting up this application, so let's pretend this is a real app actually loading data, and I'll just add less than a second, so 750 milliseconds of delay in my application, we can see now my test is going to fail. Why? Why would such a tiny amount change whether my test passed or my test failed and how quickly the application performed? The reason is, even though I'm using this command correctly, or my syntax is correct, I've defined it correctly, I'm actually misusing it. And that's because in order for me to guarantee the cy.intercept is going to work, I have to define this before the real request is actually triggered. And the real request is triggered on visit. So all I have to do, the solution to this, would be to move this code above my visit. And when I save this, it always guarantees that my intercept is defined no matter how long my application takes to load. Now I know cy.intercept is a specific Cypress thing, but the idea is I was confident that I was using my command correctly. I even had the right code, but I just put it in the wrong spot because maybe I didn't look up the documentation. Maybe I didn't truly understand how I was supposed to use it. And I accidentally created failure and flake because of that. So that's kind of tool understanding. I'm sure there are a lot more examples across many different tools, but just always ask yourself, do you truly understand what you're using? The next example about test flake is test independence. So pretty bluntly, can you run each test on its own over and over again? So a big thing about testing is you want to make sure that each test is independent of other tests. So here, let's pretend we have a test where we visit a site and we validate a text in one text and text in another test. If I were to run the second test without the first, it would fail because it is dependent on the first test visiting that site. This is bad because what if this test has a failure? This means that this test is also going to fail because this test could potentially fail. So I could actually fail a test unrelated to anything that it's actually testing, giving me confusion, giving me flake because it's dependent on something above it. So to guarantee that you always have tests, you want to always make sure that, you want to always guarantee tests are independent of one another. And the way we can do that, at least with Cypress, is by always defining shared setup in a before each hook. So now what this means is that when I run the first test, it's going to visit my site, validate some text. When the second test runs, it's also going to visit the site and revalidate different text. So if this one fails now, I know that this one is still going to be okay. It's not going to care about whatever happened in the test before it. And that's really important. I want to make sure that my test results are contained within the test itself. So that's kind of a concept that I think a lot of people are familiar with. But one thing that I didn't think of, and that has taken me a long time in my career, is to also consider retriability. Ask yourself, can you actually retry a test? So let's pretend that we have a user table and I want to submit a new user into that table. So it's very simple. I type a first name and a last name, I click a button, and I validate my user exists. So again, very, very straightforward. When I run this test the first time, it's going to work, right? I add a user, I click submit, and then all of a sudden, my user's in the table. Cool, everything is amazing. This is wonderful. But if I try to rerun this immediately after, what's going to happen? I'm going to try to submit the same user. I'm going to click submit, and it actually might fail. What if the API checks to see if that user already exists? That API call is going to return a 500 or a 404 or something, and it's going to say, you can't submit the same user twice. So I wrote a really good test, but I wrote it in a way where it could only be run once, right? So how do we fix something like this? Well, we need to clean up what we've generated in the test. We need to have confidence in our data, and that's a really big topic we'll focus on. So one way I could do this is clean up the user after I've created it. So I could come in here and I could say, like, let's pretend we have a delete button, and then I could do click, and then I can click my, I can click that delete button after I create the user, and then I can even come in here and maybe I just say, like, there's a confirm button now, and I want to, like, confirm the delete. Okay, cool. That should work, right? Every time I run this test, I create my user, and now I'm going in and I'm cleaning it up. But there's also a problem with this. This might work, but it could also be flaky. The problem is, what if this line fails here? If this line fails in the test, these lines are never going to be executed, which means that if I rerun the test again, this user is still going to exist. It's not cleaned up. And now I'm stuck once more. My test is now going to fail, and now it's going to fail here again on submit. So this is a problem. How do we continue to clean up this test and guarantee that it always works? Well, what I could do is I can actually, and what I would recommend is always handle your cleanup before the test begins. So we could come in here actually, and we can visit our site first. We can click the delete button, confirm it exists. We can even have some sort of conditional where we can check if the user exists. And if it does, then we click the button and delete it, right? So this is a little bit better, where if the user exists, we come in here and click it. This is just pseudocode, of course, and then we can re-add it. But there's still a problem with this. What if the delete button has a bug? Or what if it doesn't exist? Well, all of a sudden, now I have my test to submit a user is now dependent on delete working in the UI. So again, it has a dependency when the test is just about submitting. So I don't even care about this UI. So the best way that I can do this is to programmatically set my state before my test begins. And this is really powerful. Cypress has something called custom commands. And what I can do is define a custom command where I can make real API requests, fetch all my users, check if the user I want exists, and then delete it programmatically. This is not only faster, but my test is not dependent on certain UI existing for it to work. All I need is these APIs to work, right? So I come in here, clean up my user, visit my site, add it again, rerun the test, and it works seamlessly. I'm not dependent on any sort of UI being there that it shouldn't, and I can rerun this test over and over again. This is a really important thing and concept that I don't think, or at least it took me a long time to realize. Okay, moving on, and a big one is discussing local versus the pipeline. I'm sure a big pain point of many, at least definitely me. So this is actually a real picture of 5 of my real specs at work. Blue is how long it took me to run my tests locally in seconds, and green is how long it took me to run it in the pipeline. So we can see that in some cases, or all cases, it was significantly faster in the pipeline than it was locally. This one was even 3 times faster. So why would this be? When I run something on my machine, why does it take so much slower than the machines on the pipeline? And how can I always guarantee that all of these tests are going to pass, even though there are these such potentially large differences in how fast they take to execute? There are some tips and tricks we can do to kind of harden your tests to make sure that they're always working regardless of the timing of things. So for local versus pipeline, what are these differences? Well, for me, the main, obvious one is differences in resources. Maybe the machines I'm running on the pipeline are just they're stronger. They have more memory, more execution power, right? They can handle requests a lot quicker than my local machine. There are also differences when the DOM reloads, right? And how often, how fast. And not as big of an impact, I think, but browser versions can also matter, right? What if my local, I'm testing against, a Chrome version that's like 10 behind the one on the pipeline? Could that have an impact? I don't know, but it's something to consider, right? It's a variable that maybe we want to ask ourselves, should we try to control that? Can we actually trust the environments we're running against? Are they actually reliable? These are really important questions, especially when you give your automation tests almost into the hands of something else, right? In the pipeline, you have to have really full faith that whatever you're giving your child your automation test to, that they're going to take care of it. So let's talk about some different ways that we can harden our tests in the pipeline. A first and kind of big one is always adding dynamic weights before you assert something. So if my pipeline executes this test faster than my local environment, what's going to happen? So we have our submit user test again, right? I run this locally, and again, it works. I submit my user, then I come in here and I validate a user table. Boom, everything's happy. But if I run this test super quick, this could actually fail. What happens is that after I click submit, Cypress is already going on to the next change request, and it's validating the user table. Well, if this test is running really quick, what if this user hasn't fully refreshed and I'm actually trying to execute this test too fast? What if the post call here to actually create my new user hasn't completed? What Cypress could do is it could validate a user and look for the table before it's not actually refreshed in the DOM yet. So what I need to do is I can add a dynamic wait before doing an assertion here. Excuse me, sorry. So we can use CY.intercept again and define some sort of intercept here where I can call this post, and then we'll just call it like my user endpoint or something like that. And then what I can do is after submitting and clicking here, I can call it post user users. Excuse me. I'm so sorry. I have a typo here. Okay, so what I've done, and I don't know the equivalent commands in Playwright or Selenium. I'm sure it's like async await, but what you can do is you can always guarantee that after I click submit, I'm always going to wait for that post to finish before I do an assertion. So that means this post can take super slow or super fast, and that's okay. Regardless of that, I know that I'm always going to assert in my table after this has completed. So this now removes the variability of timing. I can also do, at least with Cypress, inline timeouts, and I can say something like, wait up to 15 seconds until you actually find this text. So this is kind of cool. This means it's not only waiting 15 seconds, but it's waiting up to 15 seconds to find it. So it's pretty neat. And you always want to kind of using these two tricks throughout your test always guarantees you're removing the variability of timing of real requests in and out of your application. We can kind of control some of that and say, and let the test wait as long as it needs to. So we've talked about waits, but what's the idea of maybe a bad wait, which would be explicit waits? So I could also come in here and I can just do something like this. So this means wait 15 seconds. Again, this would fix the test and it would probably be okay. Our test would never break. Chances are this post is never going to take more than 15 seconds. But what I've done here is now this test waits 15 seconds every single time. What if my post call only ever takes 5 seconds? Well, that means I'm actually padding my test by 10 seconds when I don't need to. Explicit waits are bad because you're making an assumption on a specific timeout and you're unnecessarily extending your test potentially by a significant amount of time. What if the submit button eventually takes 20 seconds? Again, this is going to fail now. I am dependent and making an assumption. If it only takes 5 seconds, sure, it passed, but now I'm actually taking way longer than I need to. So using a dynamic wait of some sort always guarantees your test is going to wait only the amount of time it actually needs to, and it could be long or slow, and it's still going to work, no matter what environment it's running in. Another kind of practice you can get into is add an assertion before an action. So again, I want to type and then click, but how do I know that my input here to type is going to be ready? What I can do is I can add an assertion before I type, and I could say should be visible. Let's pretend that I want to do that. Now this means that Cypress is going to get my input and it's going to validate that my input is in a state before I want to type it. So it's only going to type it if it's visible, right? So that means that potentially if this input takes slower on one machine to appear or faster on another, I'm not going to start an attempt to type into something that doesn't exist. I'm always going to guarantee that it's there. Same with maybe this button. What if I want to validate that it should be enabled before I click it? Again, if there's ever a timing issue here, it doesn't matter. I've removed that concern. And now I know that before I click this button, it's always going to be in that right state. So let's talk about parallelizing your tests, which is something that we all want to do and we all want to achieve because it runs our test suites faster. Excuse me. Parallelizing your tests, right? When you run your tests across multiple machines and you run test suites at the same time to get your test results faster. So here we have our test where we want to submit our user again. And we can see here I'm using my custom command to programmatically delete my user before I submit it. And this test is going to work, right? We clean up, we submit it, we clean up, we submit it. But the problem is if I introduce parallelization in the pipeline, I could actually introduce flake into other tests. Why? What could be the problem? The problem is when I have hard-coded data, I'm making an assumption and hoping that nothing else is using that data. What if I'm using the user David Ingraham on another test in another file? And all of a sudden, if I run those tests in parallel, this test is going to delete David Ingraham, which might actually break another test completely randomly in another file. So when that test runs, maybe it thinks it's only using David Ingraham, but when it runs, all of a sudden another test has now blown it away and it can't find it and it breaks. So when you look at that broken test, you're like, what the heck happened? It worked on its own and it only fails in the pipeline. Well, that's because you have two tests running at the same time using the same piece of data. So it's important to have independent tests, but you also have to have independent tests that can stand on their own from other specs, even from other environments. You want them to control everything they can and not make assumptions. Again, account for all this variability. So we need to ask ourselves, where does our data come from? And how can we always guarantee that it exists and that we're not impacting anybody else? So one thing I can do to fix this and always guarantee this test won't break anything or won't be broken by anything is to use some sort of like faker or randomized data. So what I can do here is, I can't remember what I called it. Sorry, I have a util here somewhere called get random first name. Ah, there it is. So what I can do is I can come in here and I can say get random first name, and I can say last name, get random last name. And instead, what we can do is now, if I just replace, some of this hard-coded stuff with my actual variables, and I'm not going to update the rest of this just for time, but what this does is I'm utilizing Faker, which is a library that generates random data every time I run this test, because ultimately my test doesn't really care what my user's called. My test is not going to pass or fail if David Ingraham is the name of my test, right? I'm validating user submission. I don't actually care what the user is. So I can create a random user every time using random data. And what that means, though, is when I do that, this data is going to be contained within this test, and I'm not going to potentially delete something from another test, right? So consider programmatically controlling your data, but also potentially randomizing it. And then environmental data. Whenever you look at your test and you see a hard-coded value, always ask yourself, can I guarantee that that data is going to exist? Don't assume that your environments are always going to have the data they need. And always ask yourself, where does the data come from? Do you seed your data on a nightly basis? Do you seed your data at all? Can you guarantee your data is going to exist on one environment versus another? What if you have a new environment spun up? Can you actually run your test there? What's the setup going to be for that to look like? So when I look at something like this test, which is editing a user, I have a couple assumptions, even just looking at this. The first big one is this right here. This is a hard-coded piece of data. My test assumes that this user is there, which might be okay, but how can I always guarantee this user is going to exist on every environment? Where does this user come from? That might be something I want to address. As I keep looking throughout this test, here's another one. where I may be changing the role of my user to an admin. This admin is a drop-down option in some drop-down. How do I know that this option will always exist? Well, a drop-down option probably doesn't get changed a lot. So is this something that I'm okay assuming that it's always going to be there? Probably. Versus something like this, where a user, what's the variability and how confident am I that this user is going to exist on every environment? Probably not as not as confident. All it takes is one person to manually go in there, change this user, delete it, seed it, anything, and my test now fails. So you have to risk the always ask yourself and risk, or weigh the risks of hard coded data. And you need to ask yourself, what do I want to control and what do I not want to control? And again, the overall concept is reduce variables. Don't assume anything. Some other things to consider are when you run tests in parallel, can they actually handle more tests at the same time? As your test suite grows and you're running maybe 5 tests at the same time, can your application handle it? What if you have to log in for every test, but there's a rate limit? I add this one specifically because it happened to me. I ran all my tests locally and they passed. The first time I introduced parallelization, all my tests failed and I couldn't believe it. I was like, these were all passing before. I don't even understand what could have happened. And the problem is because I was running like 7 tests at the same time in parallel, I actually was hitting a rate limit with Auth0 and it was no longer allowing me to log in, which is not something I considered before. So there are other variables that I have to think about is, can you actually run things in higher amounts of load in succession? What if I have running 5 tests on my application, but my application can't handle all of these get calls at the same time? Could it actually fail some tests by accident because it's not responding quick enough? So again, you always have to ask yourself, do I have confidence in my environment? Do I know it's going to perform the same as my local? And how can I control that, or how can I get these answers? And then finally, can you always guarantee maybe environment variables are the same locally versus CI/CD? Just something I have to ask myself every single time because it is a variable I overlook. Okay, the last one and kind of type of flake I want to discuss and briefly have you ask yourself is, what about good flake? This is a concept that took me a really long time to ask myself because I never thought that flake could be good. Let me explain what I mean by that. So we have a test now where I want to delete a user. So I'm going to define an intercept to delete that. I want to visit my site, click a button, wait for that endpoint, and then validate my user's gone. Very straightforward. When I run this test, though, what happens is sometimes it works and sometimes it doesn't. It's because my delete button sometimes isn't enabled when I try to click it. Sometimes it is, sometimes it isn't, right? Maybe there's just a timing issue, how fast my application takes to load. Okay, well, we've talked about this before. We have some tips and tricks to fix this. So what I can do is potentially I can come in here and I can define a second intercept, right? I can call this like maybe get users. We can get our users first. And here I go. I can wait for my get users if I have this users call to finish, right? I want to make sure all my data is loaded before I click this button. I can also add that safeguard assertion, right, that we talked about, where I could say this, I want this to be enabled. Boom, my test is always going to pass now because I'm validating it's enabled before I click it. I'm waiting on my data. But should I have done this? Whoa, what are you talking about, David? We just talked about all of these ideas about how to bulletproof your tests, make them more confident. And now you're telling me maybe we shouldn't make your tests more confident? Why? Well, ultimately, as testers, our job is to defend the customer and the business. We want to make sure the application is the best quality it can be. And instead, I need to ask myself, is this flake in the test or is it potentially in the application? Because if I remove this code and I think about this at a high level, if my test catches this behavior that potentially the delete button isn't enabled on load, maybe a real user could catch it too. And maybe I shouldn't just be safeguarding my test. Maybe I should ask myself, could we improve the application instead? Maybe the solution isn't always to harden your tests and make them as bulletproof and to catch and handle bad application behavior. But maybe I need to go back to the engineering team and say, like, maybe this button shouldn't be ready to be clicked and we can handle that on the application side, not the test side. Because as a user, what if I go in and I also experience the same behavior? This is a really important concept, and I really want to stress that just because test flake happens, sometimes it isn't the test. And that's a really hard thing for me to learn. It took me a long time in my career, but there are a lot of other variables that can happen, including the application itself. So those are different types of flake. Let me pull up the, sorry, I have so many tabs. Here we go. I'll just pull up my presentation again really quick. And I guess just I want, as a recap, to stress that test confidence is everything. You have to have confidence in your tests. Ultimately, if you don't, then what's the point, right? We can't trust them. And you're just kind of spending your time doing something that isn't proving and providing value. Flake is really, really frustrating, but by taking a step back and breaking down the failure instead of randomly guessing or covering it up will actually save you time in the long run, and you'll actually fix a real issue, which, you know, feels pretty good. Debugging and handling test flake, it doesn't have to be a stressful and painful experience. It can be enjoyable and calm if you just start to ask yourself the right questions and start to think about why is it failing. So just be patient, but move fast. And remember that ultimately you're not alone. There's a lot of informative resources online, including, of course, the amazing Test Tribe, Discord community in general. So if you run into a problem, chances are somebody else has as well. So yeah, thank you very much. Hopefully this has allowed you to think about different ways to approach your tests, harden your tests, and think about improving your tests so that they're resilient across all different variables. So thank you guys.
Hey, David.
Hello.
Yeah. So we have few questions. I'll just pick it up from here.
There looks like there is one question that if we have a minute, I do want to talk
Yeah,
about, because I
just
think it's
yeah. Do you
about
recommend having retires in the?
yeah, I think that's a really good question. So absolutely, but you need to understand the purpose of retries, right? You do not want to use retries to cover up other issues that you can solve in your tests or in your application or in your environment. I use retries to handle the most unexpected variables, like what if my network goes down or the environment just has a hiccup, right? There are just 100 variables, and honestly catching them all is just kind of it's impossible. There are too
Yeah.
many things that happen in our day-to-day life. So
Yeah.
if I have a retry on, I want to use that as a fallback to catch maybe the rarest things,
Yeah.
but I don't want it to be a crutch to cover up common problems that I can solve myself.
Yeah.
So I think you need to use retries, but with caution, and you just need to be confident that the retries aren't going to cover up bigger problems.
Perfect. Thank you. Thank you very much, folks. Any other question? Okay, there's one more. The folks, this will be the last question I'm picking up. How can we mitigate flaky jobs?
Uh, I mean, the flaky jobs, it all depends on why is it flaky, right? What's actually happening in your jobs. This section where I think you need to talk about, or maybe focus on again, is local versus the pipeline. If you only have tests failing in the pipeline, is it a timing issue? Is it an environment issue? You need to start asking yourself these questions. And I think or at least hopefully I provided a lot of different questions and things to maybe start looking into in that little section. So that's what I would focus on. I don't, yeah. And I think it just I'm so sorry. A lot of it comes down to is, yeah, I think I answered it. Sorry. I'm done.
Yeah. Thank you. Thank you very much, David, for taking our time. Please take care of yourself. I just hope you get well. So yeah, perfect. Thank you. Thank you very much, David. Okay. Bye bye. Happy testing.
Happy testing.